Good morning. We are moving on to section 1.4 today, and 1.4 is literal equations. And if I look at the word literal, think of literature, stuff you read, letters, words, symbols. Easy definition. A literal equation is simply an equation that has two or more variables. An equation that has two or more variables. And what we are going to be doing with these literal equations, and the idea behind literal equations, is when I have multiple variables in a problem, I can isolate or get one of those variables by itself, and then I can reuse that formula or equation over and over again, solved for the variable that's most useful in terms of the problem. Easiest way to do these is look at examples. 2y plus 5x is equal to 6. And the biggest thing that I have students do when we start solving these literal equations is they're always looking to give me an integer answer or a number answer. They'll tell me, well, x equals 2. Well, x is 2, but don't I also have a y? We will learn in a few chapters how to solve equations with two variables in it. But right now, we are just going to solve for one variable. We are just going to simply get a variable by itself. I'm not going to have a number answer. What I'm going to have is a resulting equation. So in this problem, I will tell you that I would like us to solve for y. And you will be told which variable to solve in the problem. I am looking to get that y right there by itself. And my thought process is the same: to get this y by itself, to isolate this y, to get it alone on one side of the equation. I want this to say y equals something. Again, I'm just going to ask myself, what's happening to y? Well, it's being multiplied by 2 and added by 5x. You need to reverse that by subtracting 5x and then dividing by 2. So my first step to get this y by itself is going to be subtract 5x. What I do to one side, I do to the other. The 2y stays because I'm still looking to get that y by itself. Inverse operations takes care of that. That's exactly what I'm looking for. And then I come to this right here. And this is why we did so many things combining like terms. With these literal equations, 9 times out of 10, we're not going to be able to do anything with what we move over to the other side. The terms are not going to be like. They will be unlike terms. I cannot take 6 minus 5x. 6 minus 5x is not 1x. The 6 doesn't have an x with it. These are not like terms. I can't combine them. I just leave them. And I want you to get into the habit for what's coming in chapter 4 of writing this x term first, especially when I'm dealing with the equation with y and x, because we will actually be working a lot with what's called slope-intercept form, and we'll want that y on one side, the x first, and then some number. So this I will write as minus 5x plus 6. And you could certainly have 6 minus 5x. Those are exactly the same. The order's just switched. I'm going to write it with my x first. But if you wanted to write 6 minus 5x, you are more than welcome to. Biggest mistake students make is combining these unlike terms right there. I can't put those together. Second biggest mistake students make is when I go to divide everything by 2 now, I know y is being multiplied by 2, and you guys know that I undo multiplication by division. And when I divide, I would like us to do it like this. I'm going to divide this by 2, the negative 5x by 2, and the 6 by 2. You need to reduce and simplify each one of these terms. This simplifies into y. The 2's divide into each other. Negative 5x over 2. Well, it's negative 2.5x, but I want to get in the habit of leaving this as a fraction. Negative 5 halves can't be reduced. They are both prime numbers, 5 and 2, meaning they only have factors of 1 in itself. I'm just going to write this as negative 5 halves x. Now my x can go here out front, or it can go in the numerator, but where it can't go is the denominator. We talked about that earlier in the year as well. This fraction is reduced. Positive 6 divided by 2, half of 6, or 6 divided by 2 is 3. And I now have y by itself. I have just solved for y. I will box that in. And again, look at what my answer was. It wasn't an integer or a number. It was simply an equation. It was just the equation rewritten, solved for one of the variables that was in the equation. We'll look at another one. 12 now is equal to 6x plus 3y. Exactly the same equation, except now my variables are on the right, and we can surely handle that. We are still going to solve for y. Y is being multiplied by 3, added by 6x. That's a positive 6x there. Added by 6x, multiplied by 3. That's what's happening to my y right there. That's what I'm looking to solve for. First step, I hope you're thinking I'm going to subtract 6x. And again, 12 and minus 6x, negative 6x, are not like terms. I can't combine those. I just leave it. I'm going to write this one as just 12 minus 6x. Inverse operations takes that away, is equal to, and I just have my 3y. And I'm still looking to get that y by itself. Y is being multiplied by 3. And just like we did up here, I need to divide each term in those equations now by 3. And now I need to look at each of these and simplify them. I need to reduce the fraction if possible. 12 divided by 3. No, 12 divided by 3, that would give me a 4. Negative 6x divided by 3. Negative 6 divided by 3, that's going to give me a negative 2, and I still have my x, equals, and then those 3's divide into each other, is equal to y. And now I've got y by itself. And you could easily write this a couple of different ways. You could write this y is equal to 4 minus 2x, if you want your variable on the left. You could rewrite this one based on the logic we used up here. Y is equal to negative 2x plus 4. All of these are acceptable answers. I'm going to box this one in right here because that's the one I got first. But just know that this can be rewritten two different ways. I could even have negative 2x plus 4 over here and my y on the right. I could even write it another way. Next example. 5y subtract x is equal to 10. solve for y. Go ahead, push pause on the video, take a second, see if you can get this y right here by itself. Okay. Y is being subtracted by x and multiplied by 5. Subtracted by x, multiplied by 5. My steps to get y by itself, add x. 5y stays. Inverse operations takes care of that x. And then I have a 10 plus x. That is not 11x. That is just an x plus 10. They're both positive. These are not like terms, I can't combine them. 9 times out of 10, like I said, you are not going to be able to combine the terms when you move them. Now, I'm still looking to get this y alone. Y is being multiplied by 5. So I will divide all things by 5 on both sides. If I don't divide everything by 5, I don't have equivalent equations. I can't just divide this by 5 and the 10 by 5. You have to do everything by 5. When I do it by the same number, I don't change the value of the original equation because I'm doing it to every term. Once I divide, I'm going to reduce or simplify. 5 divides into 5. That's what I want. Y then is equal to x over 5, or x divided by 5, plus 10 divided by 5, which is 2. Here's my answer. Also, I know that dividing by 5 is the same as multiplying by what fraction? Well, it's just 1/5. So I could also write this as y is equal to 1/5 times x plus 2. What you can't have is that, not 1 over 5x. The x has to be right even with the fraction bar, or it has to be in the numerator. Either one of those answers are acceptable. All right, I'm going to flip my paper. This is just dealing with x's and y's. Now we're going to get into some formulas and manipulating formulas. And this is super handy as you move forward in biology, in chemistry, in physics. You will use these literal equations all the time. Surface area of a cone. Off the top of my head, I don't necessarily know the surface area of a cone, but I will tell you the formulas that are there. A cone, just like this, just like a cone that you would see in the road. An upside down ice cream cone. Now that's not the most pretty picture of a cone, but it'll work. What we're going to be dealing with is the formula that will tell me the surface area of a cone. And that happens to be S, or surface area, is equal to pi r squared, because that's going to give me the surface area of that circle in the bottom. But I also have the surface area of this top part, and that is going to be pi times the radius times the length of one of these sides of the cone, the link here. We are going to solve for this L. I need to get that L by itself. In this problem, I happen to have 1, 2, 3, 4 variables. And we're just going to get this L by itself. You are not going to be able to tell what the L is unless I gave you values for the radius and values for the surface area of the cone. We're just going to try to isolate this L. And again, I ask myself the same questions. L is being multiplied by pi and r and added by pi r squared. To get this L by itself, I need to get this pi r squared over. Keep it together. There's multiplication between here. This is one single term. My first step would be to subtract pi r squared. And I do that from both sides. So my left side now is just simply s minus pi r squared. I have nothing that's like there. I can't combine anything, I just rewrite it. That will be equal to, that will disappear. And then I'm left with my pi r L. And I am still looking to get that L by itself. And again, I have multiplication between these. You could certainly divide by pi and then divide by r, but since there's multiplication here, I'm gonna do this in one step. I'm gonna divide both sides by pi r. So on the left, I have s minus pi r squared divided by pi r. Those divide into each other. That's equal to my L. The length of this part of the cone here, or the slant height they'll call it, is equal to the surface area minus pi r squared divided by pi r. We could use this formula then. If we knew the radius and the surface area, we would just simply plug these into our calculator and get our L. I could use this formula over and over and over again. It's solved for L. I could also solve this for R. It's already solved for S, and pi is just a number. Last example, and you guys will see some problems, and this will help you in your practice problems. We're going to look at temperature conversion. And this is a formula that you may even use this year in your science class. This formula is used to take degrees in Fahrenheit or Fahrenheit degrees to degrees Celsius, Celsius degrees. Degrees Celsius, degrees Fahrenheit. And hopefully we've heard of those. The formula is, I take the degrees Celsius, that will equal 5/9. I'm not going to use a multiplication symbol there. I will use parentheses. Times degrees Fahrenheit, subtract 32. And I'm going to ask us to solve for F. Solve for F. I want to get this F by itself. And when I look at this right here, early on when we're doing these, and I've introduced this before, but we'll revisit it and we'll keep revisiting it. Absolutely, when you see these parentheses, you could distribute 5/9. You could have 5/9 cents, 5/9 F minus 32 times 5/9. That becomes messy. That becomes messy. You're going to have a common denominator. Potentially, you're going to have to distribute a fraction. We don't like that. I want to get rid of this 5/9 so I don't have to distribute it. If I gave you the equation 5/9 times x is equal to 32. This is a simple one-step equation. You would say, well, if I'm solving for x, Mr. DeLong, I would divide by 5/9, which means I multiply by the reciprocal of 5/9, which is 9/5, and what I do to one side, I do to the other. If I multiply by the reciprocal, we know when we multiply by the reciprocal, my product is always 1. That makes it really nice over here, because if I multiply by the reciprocal of 5/9, that's going to make this a 1 out here in front of this parentheses, and then I can easily distribute a 1. Well, it's just the same thing what's going to be in the parentheses. Remember, this is a single term, just like this x here. It's being multiplied by 5/9. The f's being multiplied by 5/9, and so is the negative 32. But if I multiply by the reciprocal on both sides, this becomes 9/5 times my degrees Celsius is equal to, this is why I multiply by the reciprocal, because I know when I multiply reciprocals, my product is 1. Those all divide into each other, and I'm just left with f subtract 32. I'm still looking to solve for this f right here. It is being subtracted by 32, so I can add 32. What I do to one side, I must do to the other. This certainly doesn't have a c with it. I just rewrite this. It's 9/5 times whatever the degrees are in Celsius. If I add 32 to it, that's going to tell me what my degrees Fahrenheit are. And I can surely rewrite this. Just going to pull this over here. Degrees Fahrenheit then equals 9/5 times the degrees in Celsius plus 32. Here was my general formula right up here. Degrees Celsius is equal to 5/9 times f minus 32. And we solved this for f right here. Now I have two formulas, one for Celsius and one for degrees Fahrenheit. So if somebody would give me the degrees in Fahrenheit, I'd plug it in right here and I'd have the degrees Celsius. If somebody gave me the degrees Celsius, I'd plug it in right here and I'd have degrees Fahrenheit. That's why we use literal equations, to rearrange them to make them useful so I can use them over and over again. Last example we are going to look at is area of a triangle. We have looked at area of a triangle in here before. Area of a triangle is equal to 1/2 the base times the height. And we've went over that in here before. We have derived this formula from the area of a rectangle. This is one that you should know and commit to memory. Area of a triangle is 1/2 the base times the height. I'm going to ask you to solve for the height, or solve for h. I'm looking to get this h right here by itself. Solve for h. I'm going to rewrite this area equals 1/2 base times height right there. You want to get this h by itself. Right there. Again, you have a fraction. Clear that fraction first. This is all multiplication here. How do I clear the fraction? I would divide by 1/2. Dividing by 1/2, multiply by the reciprocal. The reciprocal of 1/2 is 2 over 1. That's going to clear that 1/2. 2 times A, 2A. Multiplying by the reciprocal gives me a product of 1, so I'm just left with BH. You are looking to get this H still by itself. H is being multiplied by B. I will divide both sides by B. That means 2 times the area divided by the length of the base of a triangle is equal to the height of the triangle. And I have my answer. I hope you could see that I could easily manipulate this equation here to solve for B. My steps would be the same. I'd multiply by 2, but then instead of dividing by B, I would just divide by this H here. So actually, the base of the triangle would be equal to 2 times A divided by B. Or I'm sorry, 2 times A divided by H would be equal to B. Hope that helps. Give these practice problems a whirl.